Going to use N4.11. There we go, version 4.11.1.16. We're going to open up the station, the platform, sorry, with default IP address 192.168.1.123. Accept that. So it's not going to be the usual password because it's default out the box. So Tridium Niagara, all lowercase. See if this works. So it wants me to put a platform in there now. So passphrase. Username, password, confirm password, comment optional, I'll just put name there, Max King, finish. I'm going to go straight into platform administrator. I'm going to go straight, so it's 4.8 currently, out of the box, commission. Don't need to install any extra languages, that's fine with English. Install the license, so now we can run on 4.8 with the ISMAs now. GC5 4.11, sorry, so we can work on 4.11. Click WB and UX. I don't have a station to transfer. Maybe I should make one. So let's just cancel out of that. Tools, new station. The station name, Rose Taylor, and it's a controller station. It is. Set password for it. And finish. So we've not added anything to the station, and I'm not doing anything with it. I'm just going to leave it as it is, and we will work on it live. Back to platform administrator, back to commissioning. Next, install them licenses. Next, WB and UX. Next, yes, we have got that one there. Leave the name the same. Required software cannot be installed. Why can't it be installed? Why can't it be installed? Maybe it still doesn't like 4.11 at the moment. Can't think of any other reason. It's got to be 4.11. Because even if I don't put a station on it and go next, it still won't let me. So it looks like the Mac 36 is still not sorted for 4.11. Okay, let's load up 4.10. platform. Accept. I presume we're still going to be Tridium Niagara. No, we're not. So it saved the username and password. Platform administrator. Commissioning. Leave that as it is. Install them licenses. Next. Next. Let's transfer that station. It's not in there. Let's just do a next, see what happens if it lets us go to the next. Looks like that's working. Yes, it is. Okay, so we can't put 4.11. Let me cancel that. Let me just make a new station. Rose. TAYLOR. Next. Set password. Finish. I'm not going to do anything with that station. I'm going to go straight into my platform. Commissioning. Install them licenses. Transfer station. There you are. Next. Upgrade all out of date. Next. Next. We'll put in the second address. 10.0.0.125. 255.255.255.0. You leave that as it is. We'll leave the default as it is. We'll put some DNS servers in just for the hell of it. So we'll do the Google servers. Next. Leave that as it is. Next. Finish. We'll let that do its stuff. So yes, 4.11 at the moment then you can't commission a Mac 36 using 4.11 at this stage. That's the 8th of June 2022. So maybe in future you will, but the highest I can go up to at the moment is a 4.10. Unless there's something that I don't know about that I need to download or update. Okay, so that's booting. So let's wait for that to boot up. So I've been on the globalcontrol5.com website that manufactures the ISMA, and I've been into support the Mac 36 NL software bundle, and I'm just downloading currently the ISMA Mac 36 files installer v1.6 release. So I'm going to have a quick look inside there and see once it's downloaded what files we've got inside there. Right, that looks like it's downloaded. I'm just going to close down, file, log off, file, close window, and then I'm going to look at this file. No, it's 4.10 only. We don't have anything yet. Well, let's install it anyway. So let's go back, let's just unzip that. Extract files, okay. And just run that. And that installs it in all the Niagara versions I've got. So it's actually installed something in 4.11. The clean disks, some ISMA, HDMI, the latest I/O, and that's it. But we're only going up to 4.10, so we still can't use 4.11. Right, so let's load 4.10 back up. That would have booted by now. Platform. Application director, see what's running. Yeah, station is running there, 4911. Haven't done anything with it yet. That's all started. So I'm just looking at my other screen to see what I/O I've got to put on there. Not that much. Some air source heat pumps, some metering, and it's just using the ISMA Mac 36. So I have nothing on this at all, as you know. So let's do new. ISMA I/O network. That's a good start. Error. That's also a good start. So we're not going to have, so we need to put some items across, because we just put a blank station on, didn't we? So let's do that. So I know we're using M-Bus, so we will need M-Bus. So install M-Bus. Probably be doing some reporting, so I want to install Vicon. Don't know if we're doing the weather, but let's do that as well. Install Vicon, install. This puts my kit control on, which is nice. Now we want the ISMA stuff. I'll put the ISMA modules on. And I think I will leave it at that. Commit. Needs rebooting. Restarting. It's chucking it down out there. Put this on pause. Now that's loaded. Now let's see what we can do. New. Alright, you're having a giraffe. Missing module is Mario. Well, at least you're not rebooting. Try for the third time. Thank you. And we've got a bus. Now we've also got a COM port as well, but I don't know whether the air source heat pump that we're talking to is actually going to be air source. Oh, Modbus registers. That's already telling me then. Okay, so that's the air source heat pump Modbus registers. So we're definitely, let me just bring that across so you can just see that. So we're definitely talking Modbus, so I need Modbus on there. Now that doesn't tell me whether it's Modbus IP or Modbus RTU. So I think I'm going to bring both across. So let's go back to our software manager. And let's bring the Modbus. Async, which is the RTU. And then we'll go for TCP, which is the IP, and we'll commit to that, and it hasn't asked to reboot, so that's another good sign. So let's bring our Modbus, we'll do Modbus Async first, and we'll leave it at that, because I presume it's going to be Modbus Async. And that's going to be COM port 1. So let's change that, because that's going to be COM port 2. So views, AX property sheet, serial, COM 2. Now normally MBus we work at 2400. Let's leave that as it is. Save that. So that's now okay. Modbus, and that's going to be our COM 1. We'll leave it at 9600, 81 and non-parity. I don't know what the heat pump is, but that's common. So there our drivers done. So what we've got to do now is bring in our ISMA network. So new, IO device 1, we'll leave that as default, we're not going to change anything. New. So let me just flick this sheet over so I can see what IO I've got. So I've got 1, 2, 3, 4, 5 temperature sensors, that's all. UI1 to UI5. And they are all going to be 10K3A1s. And I can just name these now. So that is OAT, outside air temperature. That one is space temperature. 1. That one is space temp 2. Boiler common flow. Boiler flow. Boiler return. And UI9 remote extension timer, UI 6, 7 and 8 is spare, so UI9. So let's put them in there at the moment. So 1, 2, 3, 4, 5. Six, 7, 8, 9. Well, let's do remote extension timer UI9. So that's going to be a button. So let's put everything else as digital inputs. 1, 2, 3, 4 at least. I'm going to delete some of these. No, they are digital inputs. We don't want any of them. Sorry. New. Universal input. 4 of them. But they are going to be digital. So 5 is not being used. 6 is not being used. Sorry. 5 is used. 6 is not being used. 7 and 8. So both of them are not being used. And that is remote extension timer, which would be a button, that's all. So that's it for the inputs. I'm just checking now the outputs, what we got for the outputs. So we only have 4 outputs here. They're all digital. Non-analog is being used. Yeah, all digital. So new digital outputs. 1, 2, 3, 4. 4. And that one is boiler 1 enable. So enable boiler 1. That was enable boiler 2, so we have 2 boilers. Heating pump. Let's put enable in front of it, because we can. Enable heating pump and HWS enable. Enable hot water system. And we'll select them, and we won't go for pole frequency normal, and we shall go to enable disable for them points. So we've got some electric meters. Apparently M bus air source heat pump 123, electric meters air source heat pump 123, mod bus 7 registers air source heat pump 123. So the M bus is the kilowatt hours, the electric meters, which I don't know what type yet, and we've got 7 registers for the air source heat pumps. So that is our I/O, which isn't that much. So Modbus air source heat pump 123, but we can't really do much with that, and we can't do much with that. So what I'll do now is in config, I'll just put a new folder, logic, and now we're ready to write some logic and join the dots up. This is going to be quite simple stuff, to be honest. We don't need to start bringing in, there's only one heating pump enable, so the heating pump enable and the HW, so we need 2 time clocks. We've got a space temperature sensor and outside air, so I presume we're doing outside air compensation. The warmer it is outside, we lower the set point of the boilers. The colder it is outside, the higher the set point of the boilers. We've got some space temperature sensors, so we'll probably be doing optimization, hence we want the time clock. Okay, let me put some bits together and I'll come back to you in a minute. Right, I'm just going to put these Modbus registers in. So Modbus async, I'm in there, so I'm just going to do a new device. I'm just going to add one device only, air source heat pump 1, and we've got a Modbus register of address 1. I'm not too sure how that one will work out to be, because a 1 and 2, 3 is normally like a coil, but what I think is going to be is 4001, 4002, but we'll see. So Modbus 40001 will be to ping the address, and then we'll go into that folder and our point, so we'll change that to RTU, not that it makes any difference, and we'll go into our points and we'll put a new point. They're all going to be numeric writables. We've got 1, 2, 3, 4, 5, 6, 7 points. We'll start at 4001. They are going to probably be, see, that's not going to be right, because it's got Modbus register 1 here, Modbus register 2, Modbus register 3, so I don't think that address is right, because normally you, unless, oh, there must be integer types, they've got to be integer. But outlet water temperature and inlet water, what my issue is here is normally these are floats, 32-bit, so 3 and 4 doesn't seem right, because that's a temperature sensor and I would expect that to be 32-bit, so I would expect a gap there and that one be 5. So that one would, if that one was 2, I'd expect that one to be 4, and I'd expect that one to be 6. But I don't know, let's just go on with what they've given me. Naturally they're all going to be staring down because they're not connected to anything. I don't think this is going to actually work very well, to be honest. System on stroke off. Well, that can be a single point. As an address 2, outdoor temperature. Can't see that happening, to be honest. Outdoor temp. That's not going to look right. There. Plus inf, minus inf, for infinity. That's going to be the same temperature, and that is outlet water temperature. That's going to be inlet water temperature. I can't see these being just 16 bits. Really can't. Tank actual water temperature. Tank water set point temperature. And the tank water set point, it says it's address 33. And that one was address 32. Yeah, the one before was a 4, 3, 2, 1. And then we've got address 155. And that is buffer tank. And that's got 0 to 10 degrees delta T. Tank water set point, according to this, is 40 to 65, but then it's got 75 there, so let's just do a one. Minimum 40, maximum 65. That's all we can set. And then the others are just 127 degrees, and this one is just a 0 off, 1 on. So those are registers, supposedly. So let's just stick some histories on these. Extensions, and we'll do numeric interval, because I know the client prefers interval, and he prefers 30 minutes. And what I'm going to do is I'm going to just change that parent name to parent, because I'm having some more histories. So parent, so that's the name, that's the parent, and that's it. It's going to show ASHP1 outdoor temperature, 30-minute intervals, and we'll do a config of 500 points. If we take 30-minute intervals, So that means we're going to have 48 in a day times by most 31 days in a month, 1,400. So I'm going to set that to 1,500. So we have a month's data. Save, and then I can just copy that, paste it into there, paste it into there, paste it into there, paste it into there. I might as well do the set point, even though I might as well do the system on and off as well. And then while I'm at it with these points, if I go to the ISMA.io, paste it in there, I need to change it. So we don't want the parent, all we want is that. Save that, copy it, paste, 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 and yeah, why not? I'll paste it in there for the timer as well. That one can't be a numeric interval. That's got to be a change of value, because that's going to just be a short press. 1500 32-bit parent. Save. So do I want to put histories on the boilers? Why not? Seeing me at it. So we'll do a Boolean change of value for that boiler. We'll put 1,500 points. You notice we've got no alarms in here, no fire alarm and things like that, which I find very strange. Heating pump enable, that's fine. So that's the points got a history, so that's air source heat pump 1 got a history. Duplicate that. 2's now got history. Duplicate that. 3. So I'm just going to, yeah, they can stay as they are. They're actually not going to be writable, but it doesn't make any difference. It shouldn't do. And if I go into my histories, services, history service, I've got all these histories here, and if I just go play to basically enabling more, those are all unenabled. Notice with me putting the parent in, see what happens there, which is great. Otherwise we wouldn't have been able to do it that way, because you can't have two histories exactly the same title. So hence it's put the air source heat pump before it. Air source heat pump 2 and air source heat pump 1. These don't make any difference, because these can just be parent on their own, because they're not duplicated anyway. We've got our alarm service there, which at the moment we've just got the default alarm class. And then I've just put in frost protection, which I haven't joined any points together. I am took it from here into an outside air optimizer. So if I link mark that, that's my outside air link to out into there. My frost protection, I just link mark that. Link from out into there. return temperature. So views, AX slot sheet, boiler return. And that one's not being used. Stage 1, boiler enable, frost protection. Stage 2, space temp there. So we've got 2 space temps. So let's just put a minimum block in there. Kit control. Maths. Minimum. Call it space temp. Take both them sensors into there. Link mark. Link 2. Link 2. That's going to be going out, and that's going to go into space temperature. Link mark that. Boiler return. Link 2 out. Boiler return. And that one is going to be actually rubbish. Delete that out. Put that into the control variable. That's the space temp. Third stage, second stage, first stage. That will do. Link mark that. Now I don't know why I linked that mark, because the room average is there. That's my optimizer. So that's the starting from the optimizer. Start enable, schedule start, start enable. So that's the early start, that's the early stop. So they can go to the pumps. So if I link mark that, I can actually enable these heating pumps. That's ta-da. Hot water, I think we're going to have a separate time clock for the hot water. Let's do that now. Scheduler. Domestic hot water. TC. Link mark. Link from. Out. Into 10. And we'll say from 6 o'clock at the moment to 9 o'clock. Apply Monday to Friday. Copy day. And paste that day there. That's the time clock done. So the boilers, we've still got to do boiler logic. We got our boiler return. Occupied. Well, the occupied is going to be from that into there. And that's our time clock here. So let's go 6 to 9 occupied. Clear day. 6 to 9. Apply Monday to Friday. Copy day. Paste day. Save. We've got frost protection alarm at the moment. That's because of the space temperature being minus. Frost protection 2 and 3. Wants to enable the boiler, and valve pumps not enabled at the moment. Right, so we've got that and that. That is already being enabled, I think, from the occupied there. It is. That's on. So that's already on. So there's a wire sheet. Yes, that's on. And that's on. That's boiler 2, which we haven't done any logic for at the moment. And boiler 1. Right, so we've still got boiler 1 and boiler 2. And we've got this remote extension as well to still do. So let's go to the logic. Let's just make a new folder. Remote extension. Let's put in that folder. It can be a Boolean writable because a 1 on the numeric is true. So extension required. And then we'll set that to false at the moment. And we need a set point of how many hours we're doing the extension for. So they can change it on the graphic when we get to the graphic. And we put that as a set. We don't need the in10, so we can take the in10 out. Action set, we put that to just 2 at the moment. We'll take out the decimal place, and we'll do it so we can't extend it any more than, say, 4 hours, and we can go for 1 hour to 4 hours. For the units is going to be time, and that's going to be hours. Because we work with a one shot, because we fire a one shot, and we work in milliseconds, so we go to timer, we'll take a one shot across, we'll take that into there, we'll expose the fire and time. That's 500 milliseconds. So we'll put a divide in there now. We'll just change that to a 1 just for a moment. We'll put that into there. We'll put 36000 there. Divide. Three six zero zero zero. Put that into there, That gives us 36 seconds. Minutes. One second times by 60 times by 60. There's your 3, 6 and all your zeros, which is 1 hour. I was just missing lots of zeros. Action set to 2 hours. And that sets to 2 hours, so that converts hours to milliseconds. And then that can fire that out. So let's composite them now. Composite extension in 10, and the one shot out. Done that on the wrong side. Composite, the one shot out, reverse it. That's right. AX slot sheet, extension of heating, and it's out 1. We'll continue that one. Yes. Link mark. Remote extension timer. Link 2 out into there. So when that fires, so we've got to take that into our boilers. So let's make a new folder. Boilers. So inside that boilers, we're going to have enable from a time clock. I'll put TC there, short for time clock. Set that to false. Take out the in 16. Duplicate extension. There's no safety apparently. That must be hardwired. And new boolean, so outputs boiler 1. We'll take out the in 16. But what we will do is we will add into that boiler 1 a extension discrete totalizer. We'll composite that out. Change the state count elapsed time. Action, set that to false. Duplicate that for boiler 2. We need the flow temperature on our input. Boiler flow. Set that to 0. Pin slots, take out the 16. Put it to centigrade. Celsius. We duplicate that for our boiler return. Not that we probably use it, but at least we bring it in to the folder. And then we duplicate that for our boiler set point. That we're not bringing compositing, so we'll leave that in the folder. We'll change that to set. We'll set minimum and maximum, so they can't go above 80 degrees. They can't go below I'm going to put 50, but I'll put 60. We'll also view the slot sheet, and we'll put these to hidden, so they can't do anything with that. And then let's just composite these points out. So we've got the enable from the optimizer. We've got the extension, we need to extend the hours. That's going to be an output for boiler 1. That's going to be an output for boiler 2. And we've got boiler flow coming in and boiler return coming in. I'll just take them two and move them up. Flow and return. Views. AX slot sheet. Enable. LPTZ from the optimizer. Extension. Heating. Boiler flow. Boiler return. Boiler 1. Boiler 2. When I was doing that, I was just thinking, oh yeah, frost protection, but we could do it on the same enable, but let's put frost protection in anyway. Duplicate, frost, protect. So that's going to be another enable. We'll composite that out. And we'll put that up. Use AX slot sheet. Frost protection. So we've still got the logic to do for that. Let's just join up some dots. So optimizer, time clock, extension heating, frost protection, boiler enable, link mark, boiler flow, boiler return. So that should be all the inputs done now. And all outputs. Yes, they're not. We can just do that now. Link mark, link from, boiler 1 enable into there, link from, boiler 2 enable into there. Yes, yes, done. So now we've our optimizer's still there. That's working as it should do. Outside air's in there. Start enable, override, auto, yes. Outside air in there. Space average there. Set point. Scheduler. So we can leave that as it is. Frost protection. Space temperature, boiler return goes below 20 degrees plus or minus 5, 10 either, it's 10 but 5 either way. So 35 that would go off, anything below that stays on. That's your differential. Your space temperature, if space temperature goes below 10 with 2, I think that wants to be a little bit higher. So we'll set that to 16. Frost, third stage frost, and our outside air that goes below, i.e. 0 degrees, that's our outside air, and that's our occupied. So we've got true there, but we're not, but we're occupied, so that only happens if we're not occupied. We haven't got an occupied and an unoccupied button, so we want to take that out completely and put that directly into there and directly into there. We don't need the occupied. Frost protection 1, true. Frost protection 2, true. Frost protection 3, true. I could do with resetting all these. Reset, 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 reset. Outside air, we're not using these set points at the moment. Heating high, heating low. We're not even using cooling on this job. Action set to 80. Action set to 60. 0 to 18. So 18 degrees outside we'll do 60. 0 degrees outside we'll do 80. And that's what that set point will come up with there. Use wire sheet. That's our time clock just for that output for the hot water. So we've still got to do the logic for that. Do we need to use that? I know we've changed that, but I'm not too sure whether we need to use that or not, but I'll leave it in there. BMS heating set point. Well, we can get that from the boiler, so let me expose that. There's the set point there. Action set, so let's set that to 80 degrees. We'll use it within the logic, but we'll expose it out as well. So composite, boiler set point, out. views, AX slot sheet, boiler set point. Like I said, I don't think we're going to use that, but all we've got to do now is write a little bit of logic for this. So enable time clock, or extension, or frost. So there's 3 ors there straight away. Start. Pin slots, expose this 3rd one. So we've got a true there coming out. We start a loop, HVAC, loop, PI loop, PI, boilers. Pin slots, set point control variable, loop enable, proportional integral. We'll put that to a 2 for now. We'll put that to a 1. We're doing reverse, which is heating. We put our set point in there. That's our enable. Control variable with boiler flow. We're wanting 100% because our control variable is minus. Change that because I'll probably use that for the graphics in a bit. So we'll put that to a percentage. And I don't want a decimal place. So that's my 100% out. We can either put the boilers on, boiler 1 and boiler 2, or we can duty rotate. I haven't read the desops, maybe I should read the desops. I think what I would do at the moment is I can, boiler 1 may be enough to do it, so it could be lead and lag. Let me read the desops, one moment. Okay, I've looked at the desops. There is no lead and lag, it's just boiler 1 and then boiler 2, so we'll just do a sequence start. I'm just a bit concerned about the desops and what it says about the temperatures, and we're from 8 AM to 5 PM is the time clock. So let's just do the sequencer. I'll just do a standard sequencer linear. And it's just 2 outputs. And we'll have a delay of a minute. Not 10 minutes. Delay of a minute. I'll put 0 there. So that puts that on. That puts that on. Nothing really complicated about that. Yes, what? Let's just do that time clock. So optimizer. They want 8. Let's say here 8 while 5. Copy day, paste day. And they also want the same for the domestic hot water at the moment. Well 5. We can adjust it themselves if need be. Copy day, paste day, save, views, wiresheet. The optimized start, forget that at the moment. Heating control. The heating is controlled by the Mac 36 controlling the boiler panel. This is linked to a touchscreen. Okay, so we've got a touchscreen. Below is a flow diagram dependent, so we've got a touchscreen. We've got a HDMI probably touchscreen. So let's just go into our services, not services, platform, software manager. Save that. And let's just put the driver in for the HDMI touchscreen. ISMA. HDMI. Install that. Commit. And it did a user for this as well, so we wanted a user. Just accept, duplicate, user. Just put that in for temporary for now. We need a nav file. Let's just get a nav file. Let's just save that. Files, right click, new, nav file. We'll leave it exactly as it is. File, file. And we've got to use default HX on the HDMI. Save. I don't want them messing with any of this. So let's just cut this off from them so we can't do any of that. Just workbench views. That's fine for that, but let's just make a new row. Add row. User. Okay, that would do for me for the moment. I just need to go back into users and tick on that, untick that. That would do. Okay, save. Right, well, if we're using the HDMI, we need to put that there. We need to enable that. Save. And then in our services, we need to bring the HDMI across. ISMO HDMI. Bring that across to our services. Username. User. User 1, 2, 3, 4, 5, 6. Standby enabled. False. Okay, it does get enabled. We'll put that just to 24. Screensaver. False. But if we do use a screensaver, we'll put that to 1 hour. Save. Could not connect, well you won't be able to, because we've got no HDMI connected at the moment. So the air source heat pump is optimized start, and so is the boilers. So when we do start these air source heat pumps, we're going to start them from the optimized start. So there's our optimized start. Link mark, which is the OCC. So if these points are right, which I don't think they are, but that would be linked from OCC into there, so that would give it a 1. Link from OCC into there. It's not a problem that it's a Boolean writable into a numeric. It's either Boolean is either a 0 or 1 anyway. Okay, so that's done in there. So there's the air source heat pump starting from the optimizer. That's the boiler starting from the optimizer. Now it did say heating control. It's mentioned a 3-port valve, which we don't have any inputs on the sheet for a 3-port valve, but we've got to do a 3-port valve. In fact, let's just do that now. So here's my device, new, analog output, 3-port, so valve, VALVE, 3-port, normal voltage. That's our valve 3-port. The boiler primary pumps are enabled whenever the boilers are enabled. So where we've got the heating pump there on the time clock, we need to take that out. That's our 3-port. So there's our heating pump. Delete that. I'm just going to link mark it anyway, ready. And then go to our boilers. So if any of these boilers start, so we can either do greater than 0, or we can just take an OR to these two. In case these are overridden in the logic or whatever, I'm just going to take an OR to these two. You are still running because of frost protection. Okay, I understand that now. And then what we also want to do is we want to the pump, we want to run it on for at least 5 minutes to clear the plate heat exchangers. I'll show you what I mean. So let's go an OR gate pump. Take that, put that into there, take that, put that into there. I'm going to duplicate that. Heating pump. Rename start. Then we're going to put a timer Boolean delay in there, an off delay. Five mins, I think I'll put in there. I'll expose it as well, so that off delay and off delay active, take out that. So that's in. Off delay, off of a pump, 5 minutes. I don't want to make it so they can set it, because I don't want it set really low, because I want that water to run through on that exchanger. That's heating pump done. So we'll do the composite. Heating pump out. Views, AX slot sheet, heating pump. Link mark, heating pump, link from, heating pump. That's a heating pump. So when these do go off, actions, emergency, inactive, they're counting down now, which is the 1 minute. Pin slots, on delay active, that's on delay. On delay active, 1 minute. Take that off and then that off, and then once they've gone off, this will be a further 5 minutes before it turns off the heating pump, giving enough time to run that pump through the plate heat exchangers so we don't start cracking or damaging plate heat exchangers. I don't want to be responsible for that. Back to the desops. It says here the boilers are enabled if the space temperature in the building is below 22 degrees during occupancy time based on the optimizer. The boilers are if the space temperature in the building is below 22. Well, okay, so we've got our space temperature there. Let's go. Minus inf plus inf. So if we was to follow that by the rules of what they want, space temp composite that, move it up, views, AX slot sheet, space, temperature, space temperature into there. So if that's less than 22, and we need a T-stat, you can't just say less than 22, you've got to give a bit of a plus and a minus. So space less than 22, pin slots, CV differential, CV. They said it's not adjustable, they said it's 22. And the same boilers enables building during occupancy, so we've got to have that enabled time clock as well. So it's, even though that's true, you still got to have an AND gate because it's occupancy. Move that down a bit, move that up a bit. I think we can get these boiler flow up a bit to tidy that up. Boiler return. Take that down some more. Take that out of the way. Put that up there. Right. So it is less than 22. We know that because there's no sensors attached to it, but it's not occupied as well. So until it gets occupied, we don't enable that. That's what it says in the desops. The boilers are enabled if the space temperature in the building is below 22 during occupancy time based on the optimizer. Well, that is the optimizer input there. The air source heat pumps are enabled if the space temperature of the building is below 22 during the occupancy base times. So air source heat pumps are exactly the same. So really, by rights, we want to just do another duplicate air source heat pumps enable. In fact, let's just do enable air source heat pumps. Air source heat pumps. And composite that out. Views AX slot sheet enable air source heat pumps. So link mark that. Go to my air source heat pumps that I've already put an enable to. Delete that. Link from. Enable. Views. Wire sheet. Delete that. Link from. And that one. Wire sheet. Delete that. Link from. The boiler primary pumps are enabled when the boilers are enabled. Done. Boiler heating pumps. The heating pumps are enabled if the space temperature of the building is below 22 during occupancy times. This looks like a copy and paste, or somebody doesn't. Heating control valve. The heating control valve is controlled by a 0 to 10 volt signal from a BMS. Its position is set as per the flow diagram provided based on the space temperature in the building. Outside air. So when outside air exceeds 18 degrees, the heating of the system is programmed with outside air temperature economy. Will prevent the heating enable whenever the outside air temp. So we need to stop heating when outside air is above 18 degrees. Well, let's go back into here again and let's put in the outside air temperature sensor. Duplicate OAT. We'll composite that out. We'll put that right up where the temperatures are. Views AX slot sheet OAT. So that should, if any of them are on, we can't do it with the frost protect, that must stay the same. Extension. There's no point in having an extension if we're not occupied. So that can actually come out of there now. And we need that enable as well as, so let's just put an and there, occupied extension. So we put that there, that there, so we still need to be occupied extension, then we can put you into there. And then frost protect, we've got to have you there whether we like it or not, because you are there for a reason, to protect regardless of time clocks and temperatures, extensions and space temps. Put you up there. Just neaten you up a little bit, if we can, that is. Right. Outside air, if it's above 18 degrees, just use another T-stat. OAT greater than 18. Pin slots. Control variable. Set point 18. We've got to put a diff in. So there's my oars, and I just move that across there a little bit, put that back there, and that's my output to enable my loop and my boilers. Put an AND gate in there, OAT less than 18. No. No. The reason being is my frost protect there, that can't even be in the equation. That's always going to have to be an OR after that. My frost protect has always got to be, can't be in the equation there. That can be in the equation, so that will work. That's just them two now, isn't it? That's true, that's off at the moment. Outside air goes above 18, we shut down. Frost protection is not even in that bit of equation. That will work. alarms, normal alarm stuff. HWS does the HWS secondary pump, remote access, dial in. So all we've got to do now, apart from the graphics, is get to grips with this flow chart. Below is a flow diagram depicting how the strategy in the controller has been written to control the heating using the air source heat pumps and the boilers. So start, and then we have, well, let me take a snapshot of that so you can see what I am seeing. New. The heating is controlled by the Mac 36 controller. Below is a flow diagram. So start, circ pumps off, air source heat pump maintains thermal store at 50. Is area less than greater than 22? If it's greater than 22, it goes back on itself. Circ pumps off, air source even maintains thirst. Okay. If it's less than 20, if it's not greater than 22, heat and circular pumps by the BMS. So yeah, less than 22, they come on. Is area less than 20? If it is a yes, we go up to is area greater than 22. Okay. If it's a no, so if area is less than 20 degrees, i.e. space temperature, three-way valve opens after 1 hour to 60%, taking heat flow via boiler 1 on. If it's greater than 20, but if it's still less than 20, okay, increasing heat flow via boiler 2. And if area is still not greater than 20, three-way valves after 1 hour go to 80%, heating flow via boiler 3. Well, that's good because we don't have a boiler 3. Is area 20 degrees? Yes, no. Three-way valve opens after 1 hour to 90%, increasing heating flow via boiler. Air source heat pumps are off. If area is less than 23 degrees, no. Valves open 100%, maximum heating flow via boiler. Is increased distribution max heat loss. Okay. So we have 60%, 70%, 80%, 90%, 100%. All to do with the space temperature being less than 20 degrees over a period of 4 hours. 1, 2, 3, 4, 5 hours. Right, I need to might put that in its own little folder with the logic. In fact, I will, for heating control. Call it heating control. Right, I'll start doing that. I'm going to give you a lot of break, and probably I have a break as well, and I'll start doing that folder. Alright, so that's a bit of logic for you that you've seen. I've still got graphics to do, but we can catch up on a little bit later on. Thank you for watching. Okay, I'm going back through this again. I've just added this bit at the bottom at the moment. I'm going to take out this sequencer linear and the PI boilers completely, so there's no PI. We're still going to use the output from that, but I'm going to just put that into an AND gate. Just for the moment. So that's going to go into there, and then space temperature at the moment is less than 20. So the first one is area less than 20 degrees C. 3 valve opens after 1 hour to 60%, taking heating flow via boiler 1 on. So we need to put boiler 1 on. So this is the on delay here, so that's true. So I'm switching that true, and at the moment I'm just using 1 minute. I'll change that to 1 hour later. So that is going to go to there to switch boiler 1 on. So I can put boiler 1. Okay, boiler 1 already exists, of course it does. On boiler 1. So that switches on boiler 1 currently. So on delay 1 minute, which will be an hour. So I will change that 1 minute to 60 minutes soon. That's a 60% setting. We're not asking to do the setting things, but I think this is going to change. This is wants to be will be adjustable, as well as the time delay will be adjustable. Hence, that's why I've put these in here. So we're taking 1 minute, we're multiplying it to get us 1 minute there in milliseconds, and that is less than 19 degrees, true. So normally we'll be waiting 1 hour, and then that output there will switch on boiler 1 if the occupied time clock is on. That doesn't want that. Frost protection needs to be out of there now. Still got to take that out, so take that out, and we'll put our OR gate after, because we still need frost protection no matter what. Frost protect, already got that there, so it's going to not play up with that one. So let's just put a and then we can put that back into there, and we can do that as frost protect B1, and we can duplicate that, frost protect B2, so that always takes priority. So that's stage 1, and that's at 60%. Now it says, is area still less than 20 degrees? We then open to 70%, so we can't have that. We need that to be 2 hours then now. So if we take another on delay, we'll have a rename that as on delay 1, duplicate that as on delay 2, which should be 2 hours, put that currently to 2 minutes, action set to 2 minutes, again do the percent, do %2 there, and that can be %1. then we take another delay, duplicate, so delay 2, I can say delay 1, I'm still going to take that into there, but we're waiting 2 minutes now, and then that's going to be duplicated, and they want now 70%. Yeah, and boiler 2 this time. I suppose this is what they're asking for, so we're getting what they want. So this is going to be 70%, and that's going to put boiler 2 on. And we need to join them two, so we'll just go to a maximum block. That into there, that into there, take that out, that into there, percent. So once that's timed for its 2 minutes, which will be 2 hours in real time, that will put that to 70%. So if it's still below 20 degrees, we open to after another hour again, we open to 80%. Duplicate. Three. Duplicate. 80. Action set to 80. Duplicate. We're now in the stage 3. That's going to be into there, and then we're going to be putting 80 into there, and we're going to take that into there. That's going to be set to 3 hours, but we're doing for 3 minutes at the moment, and that's going to go into there. But it says the 80% 3-way valve opens increase heating flow via boiler and boiler 3 on. Well, we don't have a boiler 3 on the points, but there again we didn't have a valve on the points as well. So let's just do a boiler 3. Duplicate. And we'll put that into C. So if that does come on, okay, why is that on and the other one isn't? Because we're not going through the time clock, are we? So we still need that and. So let's do that. Duplicate boiler 2. Duplicate boiler 3. That one's going to go into there. That one's going to go into there. That's our time clock. That's our time clock. Boiler 2 goes to there. Boiler 3 goes to there. Frost protection still goes into there. So that's 80%, and then we're doing the same again, but this is for, just move that up there a bit. So that's 4, that's going to now be 90%. Again, it's going to be for 4 hours. I'm doing minutes at the moment. Test it all. Rename 4. Stage 4, and then stage, so that's 70, 80, 90. And duplicate that again. That's going to be 5. That's going to be 100. Rename 100. So we put the in again on there. We put the in on there. There's no coming out from there. All we're doing now is changing that to 90, and then we need another maximum block. Put that into there. Take that out of there, put that into there. And that's going to be the 100%. So that's basically it. 4 minutes, 5, so 5 hours. After 5 hours, if it's not gone above 20 degrees, then eventually that valve opens to being 100%. And we can adjust the percentages using these blocks here, and we can adjust the time using these blocks here. And that's boiler 1, 2 and 3 that are on, and any one of them 3 on. Let's composite this boiler 3 to the outside. So boilers, there we go, composite. I'm going to put that boiler 3 now. There you are. I'm going to put you, move you up. Views, AX slot sheet, boiler 3, enable. That seems to have done it. That's 80% now. We're waiting for the 90 and the 100, but I'm sure that's going to happen. It's the same logic as all them. We can't put any more boilers on because we've only got 3 boilers. So the last one is 3-way valve opens after 1 hour to 100% maximum heating flow via boiler. And then it resets itself all the way back. So if area is greater than 20, then it goes right back and starts all over again, which it will do the way this has been done. Yes, it will. So it just wants a space temperature greater than 20 degrees. If it isn't greater than 20 degrees, it starts putting boilers on slowly and starts opening up a valve that we don't seem to have the point for at the moment. But I've added the point. In fact, we didn't have boiler 3 either, so let's just 3, 4, let's just enable, just put a new one in there, digital output, and that's boiler enable, boiler 3, and we'll put that to normal. So output 5 is boiler 3. So these two here are the two extra outputs. And if we go to link mark, link from, boiler 3 enable, put that into there. Again, it's still, the time clock's got to be on, of course, with the optimizer, and it's not. And the optimizer is also taking into account, so OSS set point can't be 19, link mark, so that's got to be at least 21 or 22. So this area 22 is happy, don't put any boilers on. That's the boiler set point, that's the space temperature. So really I need a set point for that, because that's the 20 there for that one. But we need to be round about 22. But everything is saying 20. If it's 22, then that's fine. I'm not going to make an adjustable. I'm just going to put that to 22. Oh no, let's make one. Let's make one and take it out. Duplicate, space, space set point. Got to change that now, so we need, go 20 there, and we go 25 there, minimum and maximum, and we'll put that to 22. And we'll composite that out. Put that just above the valve. Views, AX slot sheet, space, set point. So that's composited out to the folder. So there's my 22 there. Put that into my optimizer. 22. I think that is it. So I'm looking again at the desops about the 20s, but yeah, I think that's that logic done from start to finish. We just need to do some graphics now. %. And then let's go above set point. Let's put that to 22.5. Oops, not that lot. About 22.6. They've all gone off. Valve's now closed. And then we start again. So the first one's going to be 1 hour. Actions set to 60, which is 1 hour. Actions set to 120. Actions set 180. Actions set 240. It's 4 hours, so 1 hour, 2 hours, 3 hours, 4 hours. Actions set 5 hours. 1, 2, 3, 4, 5. So the set point goes below, the space temperature goes below the emergency override. I'll put it at 19.5. So it's a bit cold. Degrees. They're all now true. But that's not going to enable for 1 hour. So that valve still stays shut. But 1 hour's time is going to move to 60%. And then 2 hours time, 70%, 80%, 90%, and in 5 hours, 100%. And of course, the boiler's going to be coming on after 1 hour. Boiler 1 will come on, boiler 2 will come on, boiler 3 will come on. Any one of them boilers come on starts the heating pump. Outside air less than 18 shuts the system down. Sorry, greater than 18, so actions, emergency override, and we put outside air to 19 degrees. Yeah, that's now gone false. That's in an AND gate, so nothing's going to happen. The only thing that is going to happen is if we get the frost protect, which I've put to false at the moment because the outside air temperature is not reading because it's not connected. That's good. Just graphics to do now. Let's put all these, take these overrides off. And that's just for logic. Not a lot really in it. But it gives you a good idea of how we write the logic. I'm not going to bore you with the graphics. I think I'm going to end this video now, definitely. Now all the logic's done. Thank you for watching.